Okay, now we go to the next example. Example 10.7. So we have this equation that we want to solve. We want to find the answer that we want to find is x in terms of t. So what is the solution is, again, in this subtopic 10.4.1, we need to have we need to know the formula of differentiation as well as integration. So how to solve this is, we need to remember that, we need to know that d2 d2 dt2 sine alpha t. So this is a formula, is equal to negative alpha square sine alpha t. So when you take a look at the formula, this is the answer. And how to relate with the given equation is, we assume that when x is equal to this inside here, so we will get the answer like this. So we can try put it inside the equation right here. So what happen is d2 sine alpha t dt2 plus lambda square x equal to 0. So we will have negative alpha square sine alpha t is since we know that x is equal to the one inside here, so we can replace that, we can substitute. So we will get that lambda square sine alpha t equal to 0. So this equation should be 0. So alpha is the unknown that we created. So alpha can also be lambda. We can change to d2 dt2 sine lambda t equal to negative lambda square sine lambda t. Okay, now when we replace everything, so we will have negative lambda 2 sine lambda t plus lambda square sine lambda t, and of course these two component is similar, therefore it is solved that x t is equal to this equation equal to sine lambda t. Okay, so this is the solution. Alright, so now we can go to the next subtopic, which is we can have a different type of problem, which is general and particular solution. So now we want to learn how to obtain general solution for ODE, for a differential equation. So we go to example 10.8. So we have the given equation is d2x dt2 equal to t minus 3 exponential 3t. Okay, So how to solve this is simple. We just need to integrate twice. So when we integrate once, dx dt, we will get 1/2 t square minus e 3t plus a. So when we integrate, we will have additional constant, and then we integrate twice. So we will have xt 1/6 t power of 3 minus 1/3 e exponential 3t plus a t plus b. Okay, so this is the solution. This is the general solution where we don't know what's the value of a and b, because there's no other additional information to calculate a and b. So this is the simple way of solving ODE, i.e. the general solution. And if we know additional information, which is in subtopic 10.4.3, where we have the boundary condition and initial conditions. So when we know this, we can solve the constant a and b. So we go direct to the example. So example 10.9, or I think I prefer example 10.10. Okay, so the given equation is d2x dt2 plus lambda square x. This is kind of similar to previous one, I think. And the given condition is x when t is equal to 0, x is equal to 4, and we have another condition when t is equal to 0 again, the dx dt is equal to 3, and lastly lambda is not equal to 0. Okay, so how to solve this is we can use we can integrate twice again to get the both dx dt and x function or equation. So